Step 3 is by Cauchy-Riemann equation. Let's write by CR equation. Ux is equal to Vy and Uy is equal to minus Vx. So what we can say here, I can put here, let Vx will be the same. So Vx is minus 1 upon z square minus sin z. And what I can say, in the place of Vy we can write Ux. So Ux comes to be 0. So my step 4 is, I can say f dash of z is equal to ux plus I Vx. So f dash of z is equal to ux is 0 plus I Vx is minus 1 by z square minus sin z. Yes. So further I get this as I into minus 1 divided by z square minus sin z, and this is f dash of z. What we want f of z. So I can say f of z is equal to integration of f dash of z with respect to dz. So here f dash of z is I into minus 1 divided by z square minus sin z dz. So here I, and integration of minus 1 by z is 1 by z, and this comes to be cos z. So that's my f of z. We'll start with the next sum. Question number 5a. Show that function u is equal to sin x cos hyperbolic y plus 2 cos x sin hyperbolic y plus x square minus y square plus 4xy satisfies Laplace equation and find its corresponding analytic function. So what we can say here, solution is u is sin x into cos hyperbolic y plus 2 cos x into sin hyperbolic y, and further we can write as plus x square minus y square plus 4xy. So we need to prove Laplace equation. When we talk about Laplace equation, students, what is exactly meaning of Laplace equation? Laplace equation is nothing but we can also say as harmonic function. So we need to prove that u is satisfying harmonic function. That means I need to prove uxx plus uyy should be equal to 0. So we need to prove that it's satisfying harmonic function. We need to prove uxx plus uyy is equal to 0. Let's start with finding ux. So ux is differentiation of sin x is cos x, differentiation of cos hyperbolic y, it will be with respect to x, it will be cos hyperbolic y, minus 2 sin x, and sin hyperbolic y will be constant with respect to x we are doing. This comes to be plus 2x, and after that this comes to be plus with respect to x, so for y is constant and differentiation of x is 1. If you do uy comes to be sin x constant and differentiation of cos hyperbolic y is sin hyperbolic y. With respect to y, this comes to be plus 2 cos x, and sin hyperbolic y comes to be cos hyperbolic y. After that, with respect to y you are doing, so it comes minus 2y, and with respect to y you are doing, it comes plus 4x. Let's differentiate again uxx. Uxx is nothing but differentiating 1 more time. So differentiating 1, so that comes to be with respect to x we are doing, so it comes minus sin x cos hyperbolic y minus, here minus 2 sin x, so minus 2 cos x and sin hyperbolic y plus with respect to x if you do, this comes to be 2 and this is 0. So let's write uyy comes to be with respect to y I am doing, sin x will be nothing but as it is, and sin hyperbolic y comes to be cos hyperbolic y. After that, with respect to y you are doing, so plus 2 cos x, and with respect to y cos hyperbolic y comes to be sin hyperbolic y. With respect to y I will be getting minus 2. You can easily see that we need to add this to equation. When we add this to equation, what I can get, this term gets cancelled, this and this opposite, so we say that uxx plus uyy is equal to 0. So That was basically we proved that it is a harmonic function.